So here we are. We're studying arithmetic and geometric sequences in this video. We're going to be focused on the definitions and talking about all the little things that hold this idea together. So understand, on the left side we have the definition of arithmetic sequence, and on the right side we have a geometric sequence. So pause the video, copy this down in your notebook if you don't already have it, and if you don't understand it, it might be worth it to write it again and even put these into some flashcards. Okay? Really quickly, we'll talk about how an arithmetic sequence has what's called a common difference. Okay, we symbolize this with the letter D, with the lowercase d, and then we evaluated this a couple different ways, right? We've been considering it as the number that we add every time. So since I'm adding in this sequence so far, this list of numbers appears to be adding 4 every time to the last term to get the next term. Okay, and so that means that our common difference is 4. And this is the definition of an arithmetic sequence. So if we have an arithmetic sequence, then I know it should be adding the same term every time, the same value each time to each term. And if I have a sequence that's adding the same value every time, then we know that we call that an arithmetic sequence. So that's the definition. Now for geometric sequence, we have, instead of adding a value every time, we're multiplying. Okay? So 9 times 3 makes 27, 27 times 3 makes 81, and 81 times 3 makes 243. Okay, we call that value the common ratio. Okay, so understand that arithmetic sequences, we're adding the same thing every time, whereas in geometric sequences, we're multiplying by the same thing every time. Okay, to explain what it's talking about here, the idea of a ratio, and here when it says the difference, okay, I want to break that down. Okay, one thing that we could do to find the common difference is we can subtract a term. We can subtract the preceding term from a term, right? So if the preceding term to 6, right, was 2. 2 comes right before it. So I would say that 2 precedes 6, right? So 6 minus the preceding term is 6 minus 2, and that's 4. What if I do 10 minus the preceding term? Well, the preceding term to 10 is 6, and 10 minus 6 makes 4. So notice, if I do any of these operations, I'm always going to get 4, and that's why we call that the common difference. Okay, don't forget, the difference of two numbers is what you get when you subtract them. So notice they're always equal to 4. Okay, likewise, a common ratio means that if I take a term and divide by the preceding term, I should always get this value for the common ratio as long as we have a geometric sequence. All right, so if I know this is a geometric sequence, then I need to have a common ratio. And if I have a common ratio of terms, then that means I have a geometric sequence. So 27 divided by 9 gives me 3. Okay, 81, we want to divide that by the preceding term. So what term precedes 81? 27 precedes 81. And so we see that that also is equal to 3. So notice that each one of these would always give me the same value. When I divide 9 by 3, or 27 by 9, or 81 by 27, or 243 divided by 81 will still give me 3. Okay? So this is a discussion on the definition of arithmetic and geometric sequences, and now we're going to get into the handout that I gave you during class, and this is in digital form in Google Classroom. So if you go to Classroom, you can find this handout under arithmetic and geometric sequences. But here we are. Okay, we're looking at this assignment where I wanted you guys to understand the whole thing is multiple choice. Okay, in this assignment we're going to focus on reading and being automatic and making sure that we understand, wait, I don't know this quickly enough. And so we're going to develop our reflexes to this assignment. All right, so please watch this when you have some brain power and you feel like you're going to be able to think on your toes quickly. All right, if you're really sleepy, this might not be the best time to watch this video. So you got all the answers at the end. It's 102 examples. I'm going to break this video into several parts, so this will be part 1. So I hope this is useful for you. Again, we're going to start with the basics. I'm just going to go through one at a time. And if you feel like I get to something and you're like, very clear on that topic and you feel like it's getting old because I'm covering it too much, then just move on and fast forward in the video to something that is meaningful for you. Okay, and if you feel like the whole part 1 video is too basic, then you can go ahead and move on to part 2 when I actually create that. Okay, so let's start this assignment. We'll take a look. For each sequence, it says state if it's arithmetic or geometric or neither. So in this case, we should be able to tell that each term is getting multiplied by 3, right? 9 times 3 gives me 27. Okay, Negative 27 times positive 3 gives me negative 81. Okay, so notice all of these terms are negative, and so we know we don't have anything weird going on with the signs, okay? One thing that I've been talking about a lot is that, you guys might have your instincts and you just walk right up to this problem and you know that, okay? But I know that that won't be every student, all right? Some students might walk up and they might say, hey, is it arithmetic, okay? So if that was you and you weren't sure, maybe we could think about, is it adding the same thing every time? So in red, I'm going to consider what it's adding every time, okay? So notice that if I subtract 6 from negative 3, I get negative 9. But now to get negative 27, I would have to subtract 18. So notice these two numbers are not the same, right? Those two numbers are different. And so that means that since it's not adding the same thing every time, that means I know that it cannot be an arithmetic sequence. So that means I can cross that out right away. Okay, so now my mind has to be made up between neither or geometric. And of course, we're going to pick geometric because it is multiplying by the same number every time that we see here. Okay? So that's what tells us that we're okay to move on to the next problem. Okay, for number 2 right here, we should have neither. Okay, and the reason why we have neither is because it's not adding the same value every single time. We have a few issues here to deal with, right? We can see that maybe this first time it's adding 1. But then after that, it's adding 4. So that could tell me I can cross out arithmetic right away. It's not an arithmetic sequence because it is not adding the same thing every time. So now we'll go take a look at the next one. Okay, geometric. Is it multiplying by the same thing every time? All right, times 2, that makes 1. Yeah, 1 times 2 makes 2. But 2 times 3 makes 6. So these two numbers are not the same numbers. So that means we don't have a common ratio. So that means it's not a geometric sequence, which leaves you with only one possibility, that this sequence is neither. Okay, so sometimes a sequence of numbers can just be a list of numbers that are random. Okay, so that's also a possibility. In this case, we pick neither. Now for number 3, I'd like you guys to understand that a sequence doesn't have to be only integer. It can be decimals, it can be fractions too. Maybe even percentages or some other kind of quantity. In this case, we have fractions, okay? Understand that, right, negative 1/4 is equal to negative 0.25, okay? And what you guys should understand is what I'm adding every time is 2/4, right? We're adding 2/4 every time. If I add 2/4, well, what is 2/4 in decimal? Think about it, right? 2/4 is equal to 50 cents, okay? So what would that mean, right? What's negative 1/4 plus 2/4? Okay, I tried to teach you guys earlier in the year that when we have the same denominator, we can combine the numerators. Okay, so that means I can add those up because we're counting the same kind of object. Okay, and negative 1 plus 2, you guys got to understand that that's the same thing as 2 minus 1. Okay, so that just makes 1. 2 minus 1 is 1, so that's 1/4. Think about it with decimals though, right? Like I said, the negative 1/4 is negative 0.25. So what's negative 0.25 plus 50 cents? Okay, and I'm hoping that you guys understand that that is just 1/4. Okay, so look, right, if I add 50 cents to 0.25, I should get 0.25. I should get 1/4. Okay, so is this actually adding 0.50 every time? Is it adding 2/4 every time? Well, think about it. What is 1/4 plus 2/4? Isn't that 3/4? And what's 3/4 plus 2/4? Okay, that's 5/4. And then 5/4 plus 2/4 is 7/4. So it looks like we're adding the same value every time, and that tells me that it must be an arithmetic sequence. Okay, so watch how we reviewed fractions a little bit in this video, but we won't get too carried away. For number 4, okay, we're getting to a point where you guys would want to pause the video and make a selection before I start putting the answers. Okay, so think about it. In this case, you guys should be able to see that what's going to happen is if I multiply 0.6 times 5, I get negative 3. Okay, maybe that first one wouldn't be so clear to you. So what you might want to do is check all the other ones and notice, hey, wait, all of these are being multiplied by 5 correctly. So now you would suspect that the answer might be 5. So you'd have to go check it, right? And you can see that, okay, 0.6 times 5 does make negative 3. So in this case, we're multiplying by the same value every time, and so we should choose geometric sequence, okay? But you also could have seen that it can't be arithmetic, because on this time I would have to subtract 12, but on this time we would be subtracting 60, which is way more, right? These are not the same values. So that tells me that I cannot choose arithmetic, okay? So that's when you would have started to inspect whether or not it's geometric, okay? So most of this is impossible if you don't understand what a geometric arithmetic sequence is. So part of what I'm doing here is trying to give you guys the instincts, the intuition of this by doing the examples. So try on your own right now if you haven't, okay? Make a choice, pause the video, make a choice for yourself. I'm hoping that you see that this is adding 3 every time, right? So if I go here, we have 3, sorry, it's adding 2 every time, right? Sorry, it's adding 2 right here. It's not adding 3 every time. Wait, here it adds 2, and there it adds 3. So then it adds 4, and now it adds 5. So sometimes your brain will want to tell you that something's true when it's not true, okay? Like I looked at this being plus 3, and I just wanted to believe over here that 3 plus 3 was 5, but that's not true, okay? So make sure that you're thinking about it and not trying to make a pattern be true when it's not true. Okay, so now everything's labeled, right? And so we can see these numbers are not the same every time. And so this cannot be an arithmetic sequence. It might seem impossible to check whether or not this is geometric, but we got to build this up. Okay, what do I multiply times 3 to get 5? Okay, well the answer is actually 5/3, right? Let's think about that. 3 times 5/3, right? Well, what does that mean, right? I mean, we could do this a lot of different ways. We could do the number times the top, so that means 15 over 3, but that just means 5. Okay, so notice one way to do it is to cancel out the 3's and look at what's left over. It's just the 5. Okay, so there is a number that I can multiply by 3 to get 5, and that number is 5/3. All right, if you understood what I just said, maybe you could tell me, what do I multiply times 5 so that I get 8? Right? What do I have to multiply times 5? Well, I got to multiply by 8 over 5, right? Because then if I cancel the 5's, look what I get. I get 8. 8 is the only thing left over. So we got 2 different values, okay? These are not the same number, okay? We can always double check to see if 2 fractions are the same because, again, fractions look different sometimes, okay? So let's check. Is this equal? Okay, well, to see if 2 fractions are equal, you have to break them down into lowest terms. This one on the left is already in lowest terms. But on the right, 8 is equal to 2 times 2 times 2 over 5, okay? And I don't see anything that we can cancel out on top and bottom. And since these 2 fractions don't look equal, they're not equal, okay? If 2 fractions are in lowest terms, the only way that they're equal is if they look exactly the same. You understand? I'm trying to say like 1/7 is equal to 2 over 14. Those are equal, right? Okay? But this one is not in lowest terms. So if 2 fractions are equal, then that either means that one of them is not in lowest terms, or those 2 fractions have to look exactly the same. Okay? That's the only possibility. So if you want to check if 2 fractions are equal, you have to make sure both of them are in the lowest possible term, and they already are, right? So that means that they're not equal, and obviously it's not geometric, okay? So this example will be neither, okay? There's no pattern here, and sometimes those will be the most annoying because you have to check both of them, and you'll get a negative answer in both cases, right? You'll see that it is not arithmetic and not geometric, okay? So then you choose neither. All right. For this example right here, let's get an answer for you. We should have got neither. Okay, notice that it's not adding the same thing every time, and it's not multiplying the same value every time. Now we can move into this next little section. Okay, this next part is all about the function values and how to calculate them. And really, this is about what is function notation really used for. What are we trying to represent? Okay, so all of these problems, you're going to have to plug in n equals 10. And this is just me trying to make sure that you guys understand what we're doing when we're actually calculating f of 10. So, the first thing we're going to mention is that it says to find the 10th term in the sequence. And if that means we're finding f of 10, this tells me that we must have started counting at 1, right? Okay? So, the next thing that we're going to deal with is how we have our notation, right? We want to find f of 10. And so what that means is that wherever I see n, right, I'm not going to have n anymore. I'm going to go change this color to blue so you guys can see something. Okay? Make this color red, why not? So the number that's going to change is 10. Okay? Notice how when I have this one, I'm going to write it right on top so you guys can see these two next to each other. If I got f of n equals negative 20 plus 7n. Okay? Notice what changed. I'm going to go make this blue so that it stands out a little more for those of you that are getting lost here. Okay? Notice how the n and the n are right here and right there. Okay? Now when I change this to 10, this one changes to 10. Okay? So one of the big ideas of this lecture is that when we say this, right, I do not say f times 10. The way we read this is f of 10. Okay? And what that means is, what is the value I get when I plug in 10? Okay, so let's see. What does f of 10 mean? Well, it means what do I get when I plug in 10? Well, when I plug in 10, I end up getting negative 20 plus 7 times 10, right? Because it was 7 times n, and n is 10. 7 times 10 is 70. So when I take a look at this calculation that I'm doing, okay, what's happening? We can see that we have negative 20 plus 70, and that is just equal to 50. Okay, do you guys see that answer anywhere? I think we see it right here. Okay, so this one isn't necessarily one we want to do by process of elimination. I think this one you want to do directly by just making the calculation and finding the correct answer. Okay, so we'll have to do more examples, but again, we're substituting in 10 for n. So for number 8, in this problem, we want to try to calculate what f of 10 is. So to get f of 10, I wait till I get the n, and then instead of writing the n, I'm going to put 10. Okay, and I've been writing both of these in blue so you guys can kind of see it stand out against the other color. Okay, so now what's this equal to? Well, 9 is just 9, but 5 times 10 is 50. So we just have to combine those terms. 50 and 9 make 59. Okay, and we can see the answer is right here for C. Okay, so this is what f of 10 means. Okay, it's not f times 10. This is a way that we talk about the output that we're going to get before we actually calculate it. Okay, so for number 9, we're going to go through here and try to plug in the value we need. In this case, the value that we want to get is f of 10. Okay, so I'm going to copy everything except for the n. Okay, what I do for n is I usually teach my students put a blank parentheses and we'll put the number inside of those parentheses, right? So I have everything in blue, so let's put a little 10 right here too. Okay, now let's finish up our calculation. There's a couple steps that we're going to have to deal with here, right? One of them is dealing with inside the parentheses first, right? So f of 10 is equal to 2 times 10, but that's 20, minus 1, and then all of that is inside the parentheses, okay? So we'll just deal with that stuff. Just going to make sure the exponent doesn't get in there too far. So now 20 minus 1, we do inside the parentheses first, okay? So don't forget the whole point of PEMDAS earlier in the year was because we would need it, and we've reached that moment where we need to really start with all of these, okay? I need to use inside the parentheses first. That's how we got 19. So now I have to do the exponent, right? And the exponent is this little 2 that we have on both of those. So that means to do 19 times 19. And if you do 19 times 19, you'll get 361. And so our value is B, and the answer is right there. So this is mainly about substituting in values. Okay, again, we have to know about this from context. So when you see an equation that says f of n is equal to something with an n in it, you have to realize this is not a normal equation. This is the definition of a function, okay? Not just a regular equation. There's two differences, right? If I have something that looks like this, like 3 equals 2n or something like that. Okay, and then we solve it, right? This is an equation, right? This thing is an equation, okay? This is kind of an equation, but more specifically, it's the definition of this function. Okay? And in this case, we're defining the function and we're calling it f, okay? So f is something that we use a lot of times, but pretty soon this week you're going to realize that we don't always have to use the letter f. Sometimes we'll use the letter G, sometimes we'll use H, all right, but F is also one of the most common ones that we use, okay, to represent a function. So, just to finish up what we're talking about here, we want to find f of 10. Okay, so since we have our function defined by this equation, right, I'm going to go drop in the only part that I want to change, which is that number, right? What am I going to plug in for n? For n, I'm going to plug in 10, because again, it's telling us to get the 10th term in the sequence, okay? And we started counting here at the first one, so that's why we're plugging in 10, okay? So, as we go through here, we know that this is going to be equal to negative 16 plus 20, okay? And if I calculate that, negative 16 plus 20 is just positive 4. So you can see hopefully that the answer is right there on D, where f of 10 equals 4. Now for 11, we should do n squared minus 3. So then remember that we can do some of these in our head, and this is one that we could probably do on our own. So I'll say it out loud, but I'll write it so you guys have something to look at too. Okay, you should be able to do this in your head because we know that we're going to get f of 10 equals n squared minus 3. Okay, but like I said, we're going to go substitute in. Instead of having n squared, we have 10 squared now. Okay, and that's minus 3. All right, but 10 squared is equal to 100. And 100 minus 3 is just 97. And so we have our answer right here under D. Okay, so this isn't that bad once you know what you're doing, but a lot of the times the hard part is being clueless and then having the patience to let me know that you're clueless on something and that you need to kind of go back to the beginning. All right? If you go back to the beginning, I promise you, you'll probably have less stress than if you try to, you know, miss a bunch of days of school and then just see what you can learn by the test. Okay? You want to go all the way back to the beginning and go over each step, each topic that we covered. And that's why I made this assignment here, right? So we'll get f of 10. Again, as I told you in the last example, I didn't really follow my own rules, right? I told you guys to put a blank parentheses everywhere we see n, and then put the number inside there. So I'll put 10 right here, and then we just calculate what I want to do. Again, PEMDAS, right? So we got to start in the parentheses, and then we do the exponents. So first 2 times 10 is 20, right? Now we can square that. All right, well, 20 times 20 is 400. So we can see our answer is B right there. Okay? Again, just the basics of evaluating functions, working with parentheses and understanding that we're substituting in a number. So now that we're in this section, we're looking at common differences. Okay? We want to understand how to get an arithmetic sequence, how to understand what the difference is. Okay? Here, you should be able to see that it's decreasing by 100 every time, right? Minus 97 minus 100 is going to give me negative 197. So you can test this every now and then and find out. And I've noticed that a couple students maybe got stuck at the beginning, right? In a lot of ways, you know, one of the seams in mathematics is 0 being in the middle, right? And so we got to think about that. That causes a lot of stress for some people, right? If we look at this side, negative 97, okay, that tells me that this line in between there to there must be 97 steps, right? That's the length of this, okay? But on this side, we have 3 somewhere, right? And so that means I got to take another 3 steps. So how many steps would there be total, right? From here to here. There'd be 100 steps, right? Okay, because it's 97 plus 3. So you guys should understand that this is also decreasing by 100. That's decreasing by 100. And that's decreasing by 100. And so our common difference is 100. Okay? We determined that this sequence was arithmetic because each term is decreasing by 100. So now we'll take a look at number 14, and let's see what you guys get here. Okay, maybe pause it and try to figure out what you think the value is. Okay, you should be able to see that in this case, we're decreasing by 10 every time. So now we get number 15. Okay, it would appear to be increasing by 10 every time, right? From -5 to +5, and then from 5 to 15, okay? If the negative parts get you stuck, what you could do is start with one of the positive ones and then test it, right? 5 plus 10 is 15. So now we could go backwards and say if this one is also going to be plus 10, and if that one's also plus 10. All right, in this case, it turns out it is, right? They're all plus 10. So for 15, we should pick D equals 10. That's our common difference, all right? For 16, we have a new sequence that is decreasing. So we know it's not going to be a positive number. This is going to be going down every time. And it looks like when I look at this term, it's kind of obvious to see it's going down by 30. This one's going down by 30. And so this one also is decreasing by 30 because it takes 18 steps to get back to 0. And then another 12 in the negative direction. So that's 30 steps. So we can see that our common difference is -30. Okay, for 17, our common difference, we should see that it's adding by 2 every time, right? And so in this case, we get 2. For 18, we should see again, look, it's increasing by 2 every time. So the common difference is 2. It just starts at a different value from the last sequence, right? Okay, determine if this sequence is arithmetic. If it is, find the common difference. Well, we can see that, what's 3 minus 0? 3. Okay, so are all of these adding 3? Are they all 3 apart? And the answer is yes. This is an arithmetic sequence with a common difference of 3. All right, for number 20, we have kind of a weird looking pattern. Okay, is this adding the same number every time? No, it's not. Okay, and it's definitely not adding any of these. We can see that from here to here it added more than 1,000. Okay, so why would we think that the answer could be less than 1,000? So we should choose not arithmetic. I'll do some critical thinking on that one. Now here we got one, okay? Determine if the sequence is geometric, all right? And if it is, find the common ratio. So in this case, we got -4. Notice that. So one way to get the common ratio would be to take a term and divide by the preceding term. So right here, I'm trying to show you guys what that would mean. We'll do 3 of them really fast, right? The preceding term to this term, right, -256 is 64. And the preceding term before this term was the -16. Okay, what term precedes the -16? The preceding term is 4. So again, if I divide these, we will see that I'm going to get -4, -4, and -4. Okay, these values are the common ratio. So this is going to be what we need when we are trying to find R. Okay, just divide a term by the preceding term, and if you get the same number every time, we know it's a geometric sequence. So we can move on from there. Okay, the other way I showed you before, it works fine, where you can see that they have to multiply up to a value that we're looking for. So we'll think, what do I have to multiply 2 by to get 12, right? That's another way to think about it. So we've been doing them kind of like here, drawing a little arrow, and just considering that 2 times 6 makes 12, and 12 times 6 makes 72, and 72 times 6 makes 432. And we see that we get 6 every time. So our common ratio is 6. Okay, there's more than one way to do it. But at some point, you got to either think of multiplication or division. We need one of the two. So for 23, we'll get an example right here. Why don't you try this one on your own? And the answer we should get this time will be +4. Okay, because we see that it's not changing signs, right? So if the answer was -4, you got to realize that that would be a negative times a negative. And so that would cause an alternating sequence where it would be negative, positive, negative, positive. Okay, but all of these are negative. So that means that we're multiplying by a +4 every time. Again, because the sign is not changing. The sign's always the same. For 24, you guys should notice that the signs are alternating. Right? We got a negative and a positive, a negative and a positive. So in this case, we know our answer has to be a negative number. So we got to make our mind up between B or D. Okay, but we know it can't be D because negative 3 times negative 4 does not make 16. So we know it's not this one. Okay, and then we could verify that negative 4 times negative 4 does make positive 16. And if we keep multiplying by negative 4, we'll see that this is in fact the right value. So we can be confident that the answer is negative 4. For 25, again, we see another alternating sequence, right? Look, it's positive, it's negative. It's positive, it's negative. So that means our common ratio must be a negative number. Okay, and in this case, we have only two negative values, so we got to choose between 1/6 or negative 6, all right? But I have to multiply by negative 6 to get negative 12, so we won't have 1/6, all right? Our answer has to be negative 6. So now for 26, we're looking for the common ratio, and again, you guys should see that we can divide negative 27 by 9, negative 9 by 3, negative 3 by negative 1, and we can get our answer of 3. Okay, but you can also notice that if I multiply 1 by 3, I get negative 3, times 3 again gives me negative 9, and times 3 again will give me negative 27. So our answer is just positive 3. Okay, in this example, we can see that the numbers are increasing, and it looks like they're getting multiplied by 2 every time. So in this case, we should be able to tell the answer is a ratio of 2. Okay, I'm trying to focus on like the amount of time that should pass when you do these. Okay, so we get here and we look at our problem. Okay, we want to see, is this sequence geometric or not? Okay, well, is it multiplying the same value every time? It's adding 1 every time. It's not multiplying the same thing every time. So we could already tell that this is not going to be geometric. Okay, but to be really technical, I think we got to give a specific value that's not the same every time, right? So let's think about it. What do I have to multiply times 10 so that I get 11? All right, well, the value is 11 over 10. Okay, and what do I multiply 11 by to get 12? The value is 12 over 11. Okay, let's kind of prove our point. 10 times 11 over 10 is just equal to 11 because the 10s will cancel out. Okay, if I multiply 10 by 11 but then divide by 10 right after that, I'm just going to be stuck with 11. Okay, same way, if I have 11 times 12 over 11, then the 11s will cancel out, and all that's left is 12. So since these two numbers are not the same number, okay, this is not a geometric sequence. So we can go ahead and choose not geometric to finish this problem. Again, not geometric. Okay, so 29, it looks like we finally made it to another problem set. I think this would be a good place to stop that video. So we made it up to 29. Hopefully the basics is something that you understand at this part. If you're ready to continue moving on, I highly recommend you watch number 2, where we're going to get into more of the details of the recursive and explicit formula. Good luck studying.